Module 11, Hydraulic Systems. Hydraulic systems are fundamental to modern aircraft, providing a reliable means of transmitting large forces, again, as we mentioned before, with precise control using pressurized fluid. They are widely used to operate flight controls, landing gear, brakes, spoilers, thrust levers, or thrust reversers, and steering systems. Principles of hydraulics. According to Pascal's law, the operation of all hydraulic systems is based on that law of pressure. A pressure applied to a confined, incompressible fluid is transmitted undiminished in all directions through the fluid. Okay, mathematically, pressure is equal to force divided by A, which is the area that the force being applied against. So P is the pressure in Pascal or PSI, Pascal per inch. F is the applied force in Newton or lbf, pound. And A is the area over which the force is acting, whether in meter square or in inch square. If pressure is constant in a closed system, such as F1 divided by A1 is equal to F2 divided by A2, this allows a small input force to generate a much larger output force by increasing the actuator area. In other words, you would have the force being applied by the pilot, for example, during the steering of the rudder, okay? That force would go into a smaller area, okay? When it goes to a smaller area, this force increases. Why? Because it's being constricted since the pressure is constant throughout the pipe, okay? The fluid hydraulic pipe. This will cause a much larger force to be exerted against the actuator, which would transform that force into like a mechanical force. Actually, yeah, actuator area that would cause mechanical force. Yeah, the electrical force to become mechanical, okay, moving a hard part like or a heavy control such as the rudder. All right, so the force would increase when the area section, the cross-sectional area of the hydraulic pipe decreases, which will increase this force output against the actuator, which in its turn, it would allow it to move a heavy part such as the rudder within a large aircraft such as Boeing. Force multiplication. The output force produced by a hydraulic actuator is F equal P times A. For example, with a system pressure of 3000 psi, the force would become 3000 multiplied by 2, okay, equals 6000 pounds. This capability makes hydraulics ideal for high load aircraft applications. Okay, why? Because with a small force, when you have a high pressure, a much higher force would be exerted against the sectional area, okay, at the output. Why? Because you have a high pressure being transmitted within the pipe, and by altering the cross-sectional area of the pipe, you can have a larger force at the output since the pressure is constant. So you can variate the cross-sectional area at different locations of the pipe to change or alter the pressure being outputted. Fluid characteristics. Aircraft hydraulic fluids must possess low compressibility, meaning that they should not change in volume, okay, during pressure. Thermal stability, so thermally stable, meaning that the pressure should not change also due to an alteration of temperature through hot or cold weathers, for instance. Lubrication properties, okay. Fire resistance, so they should not inflame due to heat as well. Lubrication means that they flow freely within the pipe without sticking, so low viscosity, okay? And common fluids include mineral-based fluids and phosphate ester fluids, which is the sky drone. Hydraulic components. You have at first the hydraulic pumps. Pumps convert mechanical energy into a hydraulic pressurized energy. by pressurizing fluid, okay, by pushing the fluid within the piping system. Types of pumps, you have EDP or engine-driven pumps, electrical motor-driven pumps, air-driven pump, which is caused by the air pressure, and ram air turbines or RAT, which is generated like the RAT is deployed again when you have a malfunction, a flame out of both engines on the aircraft. It is deployed and it rams like it goes through the airflow, generating enough power to run vital instruments such as the attitude indicator, the VSI, the altimeter, okay, providing situational awareness that is very necessary in such case for the pilot so as to give him a chance to be able to land the aircraft. Pump flow rate, okay, or in other words, the volumetric flow rate. It is given by the cross-sectional area A multiplied by the velocity of the fluid. Q is the flow rate in liter per minute or GPM. A is the cross-sectional area, which is the area of the pipe at that position, okay, cross-section of it. And V is the fluid velocity. Hydraulic power delivered by a pump is given by P multiplied by Q. Okay, so pH, the hydraulic power, is given by P, which is the power, okay, multiplied by Q, or the volumetric flow rate. Reservoirs. Reservoirs store hydraulic fluid and serve several purposes. First, you have supplying the fluid to the pumps, of course, allowing air separation so as to avoid the formation of air bubbles within the pipe system, which can stifle the transmission of the fluid pressure within the pipes, compensate for thermal expansion so that when you have a thermal expansion, the fluid won't dilate, blowing up the pipes, okay, or cracking them. And now the aircraft reservoirs are often pressurized using the bleed air, which is the air from the airflow of the aircraft, or equipped with quantity indicators like sensors for quantity, okay? So again, supplying fluid to pumps, also separating the air from the fluid to avoid formation of bubbles and compensate for thermal expansion. So if the fluid had expanded, which is normal for all fluids, the thermal expansion would be dissipated in the reservoir. Hydraulic actuators. Actuators convert hydraulic pressure into mechanical motion, okay? So you have types of actuators are linear actuators, pistons and cylinders, and rotary actuators. Also, you have another type of actuator is the one that converts electrical power or electrical current into a mechanical electrical energy into a mechanical energy. Here, the hydraulic actuators are the ones, like the pieces, that convert hydraulic pressure, not electrical current or energy, a hydraulic pressure into a mechanical motion. Types of actuators, linear actuators like pistons and cylinders, and rotary actuators. The actuator force for a single acting cylinder is given by F equal P multiplied by A, with A is the area of the piston or cylinder in such case, okay? For a double acting cylinder, F extend is equal to P multiplied by A piston, okay? And the force of retraction is P multiplied by the area of the piston minus the area of the rod, okay? Like the moving rod of, the area of the moving rod of the cylinder. Now here, P is the pressure, okay, not the power. So P here is the pressure, A is the area. So the force being exerted on the inside of the cylinder, okay, F, that would be the pressure against that cylinder section here, okay, multiplied by the area which is pi r square, okay? The area of the cylinder, cross-sectional area, okay? Which is the cylinder bottom in this illustration. So that would be the area. The pressure is the force acting against that area. So F is equal to PA. Now for a double acting cylinder, when you have the extension, okay? Like, yeah, when you have the extension motion, this would be F extent is equal to P multiplied by A of the piston. When you have a retraction, like a reverse motion of the rod, okay, the pressure would be applied against the piston, the cross-sectional area of the piston, okay, minus A of the rod, okay, the cross-sectional area of the rod that's moving the cylinder, okay, that would be the force of retraction. Hydraulic system instruments and indicators. Hydraulic instruments allow flight crews to monitor system health and performance, of course. You have the pressure indicators. Pressure gauges indicate system pressure, typically ranging from 2,500 to 5,000 psi, Pascal per inch. You have low pressure warnings activate when the pressure is less than the minimum pressure allowed, okay? Now the pressure sensor can be a capacitor, for example, that would change based on the pressure value. It would change its own capacitance based on the pressure that would in its turn alter the area, okay, between the two armatures in which exist or between which exists the magnetic field. So by altering that area, the entire field, the entire current or the entire capacity value would change, and this would be translated into the current value of the pressure. Now, quantity indicators, reservoir quantity is displayed as a percentage or volume. So, given by Q available is equal to Q total minus Q used. Abnormal quantity changes indicate external leaks for the hydraulics, okay, hydraulic fluid, or internal actuator leakage. Temperature indicators. Hydraulic fluid temperature is monitored to prevent fluid degradation and seal damage. Typical warning condition when the temperature starts becoming greater than the maximum allowed temperature, which is Tmax. How is it measured? Again, as a recap, you have a resistance that can change value. It can change its own a resistive value based on the temperature, whether it is hot or cold. So in hot conditions, when you have an overheating, the substance or the conductive material within the resistance would start dilating, okay, and separating more and more, which would increase the resistance and it would reduce or kill the current that can pass through it. Okay, that would be translated into the current temperature within the reservoir or within within the pipe, okay, for the fluid or within the reservoir. So by measuring this temperature, you can detect an overheat or some kind of problem, okay. Now when you have a cool temperature, which is acceptable, it shouldn't be too cold, by the way, but for a moderate temperature, like the conductive material within this resistant would be close to each other, okay, allowing more current to pass through. This is how you can interpret the fluctuation of current as fluctuation of temperature and derive from it the exact value of the temperature at that moment. Failure detection and redundancy. Failure detection, you have common hydraulic failures include loss of pressure, fluid leakage, and loss of pressure can be also caused by a fluid leakage as well. Pump failure, so the pump is no longer working properly. That's why the fluid cannot be pushed through the pipes in order to activate different controls, and overheating, okay, which can degrade the chemical characteristics of the hydraulic itself. Now, failure detection relies on pressure sensors, quantity sensors, and temperature sensors. These are the three main most important sensors within the system. Redundancy concepts. Aircraft hydraulic systems are designed with redundancy to ensure safety. So, as to when one system fails, another would be backing it up. Multiple hydraulic systems transport aircraft typically have System A and System B, and also standby or backup system. Each system operates independently. They need to be standalone so that the fault in one system won't trickle down into affecting the other system and taking it down with it. This is very critical and important in safety, okay, as a safety measure. PTU or power transfer units. A PTU transfers mechanical power between systems without fluid mixing, okay? So that would be the pressure in system A or the power in system A, which can also translate as a pressure, would translate into the power in system B. And how can this take place without fluid mixing? You would have, like, for instance, let me visualize it as an example. Like, you have here a valve, or not a valve, okay, somewhat like a moving part within the pipe where you have two different fluids to the left and to the right, and the pressure here would lead to increased pressure to the right, okay? This is how you would translate the power from one part to the other, okay? Now, let's talk about emergency systems. Emergency hydraulic power may be provided by electric backup pumps and RAT or ram air turbine. Okay, the RAT deploys automatically when the normal power is less than the critical power. Okay, so one moment. The RAT or ram air turbine automatically deploys when the normal power, or like the current power, is less than the critical power, which usually happens when you have both engines at flame out, okay? When you have loss of both engines, loss of power in both engines. Summary: hydraulic systems enable aircraft to perform high force operations with precision and reliability by activating the actuators through hydraulic pressure. Okay, by applying Pascal's law, utilizing robust components, and incorporating extensive monitoring and redundancy, aircraft hydraulic systems ensure continued operation even in the presence of failures. Another detail I may have missed to talk about is how to detect the quantities in the hydraulic fluid. Okay, now you have different methods. You can use a mechanical arm that would be pushed by buoyancy. Okay, so when you have the fluid available at that level, it would move an arm as a floater. So that arm, when it floats, it would turn and like switch on or off an electrical circuit, which in its turn, okay, it would be detected as the presence or absence of the hydraulic fluid. Or another type of sensors would be the sensor that changes capacity based on the fluid that is available between the armatures, the positively charged and negatively charged armature. Okay, so when the fluid is no longer there, when it drops, what happens is that the absence of this hydraulic fluid and the presence instead of the air between the armatures would change or alter the value of capacitance. That would be detected and interpreted as the lack of hydraulic in this level, okay, at this point. So this is how it basically works to detect the absence, okay, of or the presence of the fluid at a specific level within the reservoir.